Assalamu alaikum warahmatullahi wabarakatuh. Alhamdulillah, we are approaching the end of the series of lectures, and Alhamdulillah, and well, I think it's the best time, right, for us to end lecture next week, because we are already finishing the book, and also just nice. Tonight is the 49th lecture, and next week we finish. Next week is going to be the 50th lecture. So a series of 50 lectures, Alhamdulillah. And for those who consistently come and attend my lecture for all these 50 lectures, I will say congratulations to you. May Allah subhanahu wa ta'ala bless the knowledge that you have gained from this series of lectures. And may Allah subhanahu wa ta'ala increase your rewards in the hereafter. Ya Rabbal Alameen. It's not easy, see, to follow all those 50 lectures. So we're going to cover as much as we can tonight on the last part of chapter 6 of my book, which is on the seventh earth. And then after that, if we can finish by tonight, then next week, I'm going to give a nutshell or a summary of the whole history of what we have covered right from the beginning of creation. And inshallah, if time permits, we go right to the end of the creation. Right. So if there is time next week, and if we can cover all that we can cover this tonight, and we finish the book by tonight. Actually, there are two more chapters, right? I mean, it's not called chapters; it's appendixes. This appendixes is the end of the book, and it talks about. No, it gives a brief, a rough idea on about hadith and the sciences of hadith. What is how the scholars call it the hadith, classification of hadith, and then of course we talk about the second appendices is on the second appendix is on Quran itself and tafsir, what the scholars, how they classify tafsir. Those are additional info to support those who like to know more on how the scholars classify hadith, and therefore how I use that classification, that knowledge in determining inside my book which hadith can be acceptable, which hadiths are dubious, and which hadiths can be rejected. And what about the Quran itself, the tafsir and so forth. So those are additional info for those who want to know more. Okay, so now let us move on to tonight's lecture. Let me share the screen. Now this is the screen. Okay, we have covered actually, just to go back a little bit. We're talking about how scientists classify or list down the factors that can give rise to a habitable planet. When we talk about habitable, it's defined as habitable to us. Okay, we cannot talk about habitable to other creatures because, I mean, when I talk about other creatures, those not living on Earth, because we do not know even if those creatures exist. What more, their criteria for them to exist and the planet that they reside on. So we're not talking about other extraterrestrial creatures. We're talking about creatures on Earth, especially us, right, and the animals. So for a planet like Earth, which is habitable, for it to come into existence, the scientists said there are three major factors that must be fulfilled. Number one, that it must be a right star, and that star must be a middle-aged star, just like our sun is yellowish in color. It must be rich in metal, so that the Earth or the planet that give rise, that comes together with the sun, will be acceptable because it's rich in metal. Therefore, there will be magnetic field around it, and therefore protects this magnetic field, protects the occupants of that planet from dangerous radiation from the star itself, right? Unfortunately, to find a star like our sun is quite difficult, at least in our neighborhood of stars, right? With its rich content of metal is quite difficult, and therefore the existence of a planet like Earth with a star like that, right, is, I mean, the chances are very low. Okay, now that is the star. The second factor is on the planetary structure itself. So if the star is the correct star, a middle-aged star, a yellowish star with rich metal content, Therefore, it comes together with planets. And now these planets, they must be of certain structure so that the habitable planet, if it exists, it can exist comfortably, and life can give, and I mean, life can give rise, the planet can give rise to life on it. So life can take root on that planet itself. So now we talked about the planetary structure last week. The planetary structure, like I shared with you last week, right? First and foremost, right, that planet which must be habitable. I'm talking about this thing because people have been asking on is it easy for us to find another planet and move away from Earth to go to that planet, even if we can achieve interplanetary stellar travel using sophisticated spaceships. Even if you can have that, can we find a planet like Earth? Well, the answer we have to look back at the factors that give us to that planet itself, like us, like our planet itself. So that planet, that habitable planet, must exist in what is called as Goldilocks zone. Again, I have mentioned this last week. Goldilocks is just a name of that, that's that children's story where we have this girl and she went to a cottage and she had, she saw everything in threes, and one is too big, one is too small, and the one is just nice for her. And so everything's just nice for her, right? The food is just nice for her, the bed is just nice for her, and everything's just nice for her. So she stayed there. And then ultimately the three owners of that cottage, they are the bears, the father bear, the mother bear, and the baby bear. They came back and then they claimed their own house. So Goldilocks is the name of that girl. So the scientists took that story and took the name to represent a place or a zone, right, in an orbital zone around a star when the temperature is just nice for water to exist in its liquid form. And I've detailed out what is the Goldilocks zone in last week's lecture. So I've also mentioned that if the star is too hot, right, hotter than the sun, then the habitable zone is further away from that star. If, let's say, that star is colder than the sun, the habitable zone must be closer to the star so that the warmth is sufficient for water to exist. If it goes further away from that habitable zone, then water will cease to exist in its liquid form. So therefore, life cannot arise on that planet. Now, that is number one. We're clear on that, right? So this first factor is the most important factor, and therefore, everywhere the planet, when astronomers look out and search for planets, they always try to find out if that planet exists or orbits in what is called as Goldilocks zone. They have certain calculations where they can determine whether that planet orbits around Goldilocks zones or not. So if that planet orbits around Goldilocks zones, then excitement will be, will be there. It might be, can this planet, if because it exists in Goldilocks zones, can water exist on it? If water exists on it, life on that planet? If there's life on it, what kind of life? So all those imaginations start to come in just because they found out that the planet exists in the Goldilocks zone or orbits around the star in the Goldilocks zone. So this is the most important criteria. If they found out that the planet orbits around its star outside the Goldilocks zones, then they can write it off that life cannot exist on that planet. So as of now, only one planet. This is Kepler 452b that I shared with you last week. Only one planet that exists on a Goldilocks zone that orbits around a star, which is, they call it as the Kepler star. And this Kepler star is just like our type of star, which is yellowish and middle-ish star. And they call it as G2 type star because our sun is of G2 type star also. So a lot of interest generated. There was so much news in newspaper that finally we found a planet similar to Earth. Unfortunately, if you read further, this planet, even though it orbits around the star in the Goldilocks zone, that Kepler star, right? This star is actually a little bit larger than our star, our sun, sorry. It's 10% larger than our sun. So therefore, it is hotter, right? So this Kepler 452b planet exists further away, a little bit further away from its star compared to Earth, to our sun. So when it's further away from its star, it takes a longer time for it to orbit around its star because the circle is bigger. So therefore, it takes 385 days to orbit around the sun. Well, just an increase of 20 days, that is less than a month. So it should be okay if you want to go there, right? So everything seems to be just nice. But still, we do not know whether water exists on that planet or not, because our instruments are not really sensitive right now to detect the existence of H2O on another exoplanet's cloud. So as of now, we cannot detect that. Might be in the future. Okay. But we still, or this planet 452b is still not similar to Earth, and we still cannot live on that planet, even if, let's say, water exists on that planet. Why? Because this planet, right, is, bigger than our sun. So bigger than Earth. It's bigger than Earth. So it is about, 1.5 times, 1.8 times the size of the Earth. So you look at the Earth here, and Kepler 452b is bigger than us, almost 2 times the size of our planet. And so therefore the gravitational pull is also almost 2 times. It's going to be heavy for people to live on that planet, right? And when somebody stayed on a planet with consistent strong gravitational pull and always being pulled down, right? The person's structure cannot support, our skeleton cannot support the gravitational pull, and that person can die easily. Of course, people talk about, well, if you stay there for a long time, then, evolution will kick in, and therefore, there will be creatures that can, live comfortably on that planet. Yes, but we cannot discount that possibility. But the thing is that nobody can go there, right? So even if we find a planet that is 100% similar to Earth out there, right, we still cannot go to that planet. Because why? Because of that limit of speed in our universe. We cannot go faster than the speed of light. And these stars, they are, hundreds of light years away from us. And even if we can travel at the speed of light, mathematically or physically, according to physics, it is impossible for us to travel, because we have mass. Only massless particles can travel at the speed of light. But I mean, objects with mass, they cannot reach the speed of light. And there are many other limitations. For example, if you go at the speed of light, then your time will actually, really hasten up. People on Earth observe you, your time will be really speeding up. And when you look back on Earth, people on Earth seems to be stop moving. The time seems to stop, right? Because time is relative. This is Einstein's theory of relativity. So whatever it is, right, we are creatures on Earth. We cannot travel beyond our even, our domain of our Earth and our sun. Our moon, actually. Now, when we talk about planetary structure, this is number one. Number two, right? For even if we have that right size planet in the Goldilocks zone with waters on it, still that planet cannot give rise to life if, let's say, there's no planet. Sorry, okay, I'm going to make it bigger. Okay, I think that's bigger. All right, if, let's say, there is no other planet that is as big as Jupiter right on the outside of that planetary structure. Now, why, when you look at, our solar system, we have 4 rocky small planets, starting with Mercury, then Venus, then Earth is the third one, then Mars. Then after Mars, there's a wide gap. Then after that, we have Jupiter, we have Saturn, Uranus, Neptune. All these are giant planets, really, really huge planets. Even on Jupiter, they have this red spot on Jupiter. If you look at any pictures of Jupiter, you can see this red spot. Now, that red spot is believed to be hurricanes, right? And that hurricanes have been raging for more than 300 years, because at least more than 300 years, because the first person to observe that red spot was Galileo, when he invented the telescope to look at planet Jupiter. So he saw the red spot. So the red spot was already there during the Galileo, about close to 400 years ago. So therefore, the hurricane is still going on, but the size of the hurricane is incredible. The red spot is so huge, you can observe it from Earth itself, and it's so huge that the whole planet Earth can be dropped into that hurricane. You imagine a hurricane that is bigger than the planet Earth. That is the red spot, the hurricane on the surface of Jupiter's planet. And until now, we do not know what caused the red spot, right? And what fueled the energy for the red spot to keep on moving, right? For 300 years. And why is it red in color? Might be some of the methane gases, yeah, might be that, but we're still not sure. There are a lot of discussions on it. So whatever it is, Jupiter is huge. Now, Allah created these 4 huge planets on the outskirts of the solar system. Why? Because these 4 planets serve like wipers. No, it serves like wipers. What do you mean by wipers? Because if you remember, right, I shared with you the solar system at the outskirts of solar system, right outside solar system, further out there of the solar system, there is this thing, this huge structure, they call it as the Oort cloud. That is a domain of all the asteroids and what do you call it, all those comets, right, that we can see. Comets are just, planetary, planetoid structure or some rocks or whatever out there. So there are billions and billions of rocks, right, outside the solar system. It's just like a shell, right, encompassing the solar system. And this shell is called the Oort cloud. So imagine this shell consists of billions and billions of small rocks. It's stable there. One is, once a while something happen, right, one of the rock will be pushed, nudged outside by maybe, a passing star or whatever. So this rock will travel towards the sun, and then when it gets nearer and nearer to the sun, it evaporates. The surface of this, that rock will evaporate, and the surface of the rock contains contains water. And so it gets nearer to the sun, it gets hotter, the water will evaporate and become gas, and therefore, the gas trail back behind this rock, and this rock is still traveling to the sun, and behind it is all the trail of gases, right, that evaporated from the rock itself. And this tail is what we call as comet. So we can see it as it gets nearer and nearer to the sun. That is comet actually. Now, if let's say there is no 4 planets or even 1 planet, at least 1 planet, huge planet on the outskirts, circling around the sun, and it's just, Mars and all the 4 planets, all these asteroids and rocks and whatever comets, they will surely hit Earth. They will bombard Earth, because all around the structure, circular structure of the solar system, there are billions and billions of rocks. So any disturbance will cause all these rocks to travel all the way straight to the center of the solar system, which is the sun, and we have all the planets moving around the sun, and therefore, right, we cannot escape that these planets will be hit by all those coming rocks. But if, let's say, we have a huge planet out there, right, and this planet is the size of Jupiter or Saturn, then this planet circles around the sun also. So therefore, any debris, any big rocks coming towards the sun, right, will be attracted by this huge planet, and instead of going straight to the sun, it will, bend and deflected towards that planet itself. So Jupiter, as it travels, right, because of its huge gravitational pull, any stones or huge boulders coming towards the sun will be, its orbit will be turned towards Jupiter, and it will hit Jupiter. And so therefore, Jupiter and all these giant planets, they serve as, wipers. They clean up. They are guards around the inner four planets, or the rocky planets. The third one is our planet, the Earth. And these huge planets circle around and, wipe up, mop up any huge boulders or rocks or comets that are heading towards the inner part of the solar system. So any planet that must be habitable must contain, the planetary structure must contain a huge planet, the size of Jupiter outside there, to make that planet, the habitable planet, safe. If not, it's going to be violently hit once in a while by huge boulders, and life therefore cannot exist on a planet that always have explosions, right? Comets hitting it and then destroying 90% of whatever organisms that give rise, that arose on that planet. So that planet will not be habitable actually. So the structure of that structure, that planetary structure must have Jupiter, or a planet the size of Jupiter. Unfortunately, until now we can't find any stars with a planetary structure just like ours. There are planetary structures, right? There are stars with planets orbiting around it, exoplanets orbiting around it, and those planets are all huge planets. So there's no planet that is the size of the Earth. Or there might be all small planets, no huge planets. So we are still, astronomers are still trying to find a planetary structure out there, right, with almost similar structure like our solar system, so that it will fulfill the criteria of a habitable planet. There's, factor number 2 under the planetary structure, and in my book, I discuss more in detail. Number 3, right, both these planets is habitable planet, and this huge Jupiter that serve as guard for this habitable planet, they must orbit on the same plane. The same plane means that, if this, just like our Earth and also Jupiter, it orbits in the same plane, means that same direction. This is the Earth orbits around the sun, and this Jupiter orbits around the sun, right? Almost the same plane. If you draw a line, you cut across Earth, you can put Jupiter over there. That is meant by same plane. Now, it can be a planet goes up there and it goes down and then goes up, right? While this habitable planet goes around the sun, this huge planet, right, the size of Jupiter, goes down and then goes up. Now, if that happens, this huge planet cannot serve as wipers or guard for this habitable planet in the middle, because it is very wild, right? The orbit is very wild, and therefore if there's any uh, meteorites or comets coming towards sun, it can hit this habitable planet easily, because this huge planet is not on the same plane, so it cannot clean up whatever debris hitting towards that planet, because it's up there. And so therefore scientists said that this huge planet and this habitable planet, they must orbit around its star in the same plane, right? Just like you put on the surface of paper, yeah, you put on the surface of paper like this, and so therefore this is Jupiter, this is Earth, and this is the sun. So just like our solar system lah. So if there's another structure, a star with that planetary structure, we have habitable planet here, and that huge planet must be orbiting around the same plane here, right, circling around, instead of up there and then going down and then going up. That is not conducive for life to exist, because it cannot serve its function as guard for that habitable planet which is closer to the sun. So we're still trying to find that planetary structure that is similar to us. We astronomers have yet to find it. Now, the third one is that for a planet to be habitable, the planet itself must have a single large moon. A single large moon. Now, what do you mean by a single large? Can you just hold on for a moment, because I received a call. Okay, I'm sorry. I'm going to continue a little bit later after this. Sorry. Okay, I'm sorry. Interruption. All right. Okay, so let us continue. Right. For the planet to be habitable, just like our planet Earth, there must be one large moon. Very specific, one and large. If there are two large moons, then that planet itself is not stable, because these two moons will play, tugging among each other. So if one moon is over the other side, the other moon is over the other side, this planet in the middle will be, stretched, right? Just like an oblong like that. And then if there's the two moons are together, and this moon will be, again stretched to one side. So it will be stretched and compressed, and therefore that planet will be very violent, right? There will be a lot of tectonic activities, not stable enough, just like Earth, for life to exist on it. So it must have one large moon. If it's not large, if there's one moon but it's small, again, right, that planet will not be habitable. Why? Because that planet will be, it will be tumbling here and there. Right now, for example, our Earth is rotating like this, right? And is fake. Why? Because we have our moon that stabilize its rotation. Now, if you take away the moon, now this Earth will rotate, and then it will turn down, and then will tumble over, and then it goes up back there again. Of course, we take tens of thousands of years to do it lah. But again, the Earth itself will not be stable. Imagine after 10,000 years, Singapore will be locked under an ice, because it becomes a North Pole, and North Pole becomes equator. And then after that, after 10, 15,000 years, and then it will tumble over again, and Singapore will become, like just like a desert, and then the other places will become like, tropical jungle. So it's going to be very wild. It's not as stable, no, not necessarily stable for life to exist comfortably on it. So the function of our moon actually is a lot. Our moon contributes to the stability of the Earth rotation. The moon itself is of the right size that cause, tectonic activities on Earth. So there be sufficiently amount of earthquakes and volcanoes for Earth's surface to renew itself. Because the surface of the Earth, if you have a lot of plantations grow on it, then all the nutrients will be depleted. It needs to be renewed. And this renewable soil must come from under the Earth itself. So that what's the mechanism for this soil to come up? Through volcano. That's why we have a volcanic eruption. All the soil, the lava that flows up and settle down, it becomes fertile soil, very fertile for any plantations. So that's why we have a lot of paddy plantations around a volcano. People ask, why you plant this? Is dangerous. Volcano can erupt anytime. But this is the best place for us to plant anything that we want to plant, because the soil is very fertile. It's just being, being renewed by new soils under the earth. So what caused all these volcanic eruptions and also earthquakes? Our moon. Take away the moon, there will be no plate tectonics, there will be no earthquakes, there will be no mountains, there will be no volcanoes, and Earth will become a dead planet, right? Sooner or later, nothing can exist on it, just like planet Mars. Mars actually has two moons, but they are small, very, very small. So these two moons have insignificant effect on planet Mars itself. Now, number two, the planet must be of the right size to retain water. Now, if let's say the planet is small, just like Mars, water can evaporate easily to space, and therefore there will be no more water on the planet's surface. Now, if the planet is big, therefore, of course, water can be retained, but the gravitational pull will be too strong for this water to evaporate and go higher up, sufficient altitude for it to cool down and become clouds and then fall down back as water. So the water cannot evaporate to that height, to a certain height, and then it falls back to Earth. So when it falls back to Earth, it falls back as water vapor, not as liquid water. And so therefore there'll be no cycling of water, just like on Earth. And so the water is stagnant, right? If it is salty water, then salty water forever gets saltier and saltier. Why? Because there's no rain, right? There's no rain. So a planet that is big we'll have no rain, right? The water vapor cannot rise to a certain sufficient altitude for it to become cloud and fall back on Earth. It will be pulled back by the gravitational pulls of that huge planet. And so you see, for water to recycle, it must have just nice gravitational pull, right? And that just nice gravitational pull can only come from a planet that is about the size of our Earth. Any bigger than that, then it's going to be lesser rain, right? And therefore lesser recycle of water. Fresh water will be scarce, difficult to find. Now, if it is smaller than Earth, then all this water evaporate to space, and therefore eventually after millions of years, maybe a billion years, there'll be no more water on that planet itself, just like Mars. And so all these factors actually, very, very important factors. Some astronomers, especially this astronomer by the name of Paul Drake, Frank Drake, I can't if I can remember correctly his full name, but he came up with an equation. He's just playing around. This is not really a scientific equation or mathematically robust equation. He just, used the equation to tell us what are the factors according to his, thinking that can contribute to the existence of a habitable planet with civilization, with creatures that can reach scientific and technological level, just like us human beings. So he came up with this equation and he said that n is the number of stars with advanced civilization, just like us or more than that. It means advanced civilization is defined as those civilizations that possess science and technology and already conquered electricity, chemistry, how to convert chemical to energy so that it can produce whatever things that you want to produce, right? Even rockets, if you want to produce rockets. So those are advanced civilization that have awareness and have mathematics and science. So number of stars with such advanced civilization, which is n, depends on n star here, and star represents stars in the Milky Way galaxy. So how many stars are there? Right, there are 200 billion, 300 billion stars is just in our galaxy, 400 billion stars just in our galaxy. That is a very conservative estimate. And then but you multiply that by a fraction of sun-like stars. No, not all stars, these billions of stars, right? They what do you call it as have of the same type like our sun. So what is that fraction of sun-like stars among these 400 billion numbers of stars in our galaxy? Is it 1% of it? Is it 0.5%? Is it 0.1%? Is it? We do not know the answer, right? But our latest research shown that that number of sun-like stars, right, in our galaxy, at least in our neighborhood of galaxies, is very, very, very small. Okay. And then after that, even if you have a sun-like stars, right, then how many of those stars has planets? Not all those stars can have planets, right? So how many of them have planets? So you multiply by that factor. So you reduce the scope. Now the number of stars is this much. How many of them are sun-like stars? This much. Okay. How many of these sun-like stars we have planets? Oh, this much. And then out of this much, now this number of stars with planets, how many of them have planets in habitable zone? Closer still. So you are reducing the scope, narrowing the scope. NE is the planets in the star's habitable zone. So how many of these stars have planets in habitable zone? So you narrow scope. And then after that, you narrow it some more from if you have a number of stars in habitable zone, how many of these stars with this habitable zone planet, with this planet that can give rise to life? So you narrowing the scope. And then not all life arise from that planet. If there are life on that planet, right, not all of them are intelligent, right? Just look, on planet Earth. Now, the scientists, of course, they don't believe in the story of Nabi Adam alayhi salam. They believe that, everything is because of evolution. But very interestingly is that Even if it is, even if scientists believe in evolution, we have millions, maybe 2-3 million species of animals, maybe more if you want to count from the time that life started to arise 500 million years ago. It might be 1 billion species, right, that exist or have existed before on our planet. Out of this, let's say a billion species, only one possess intelligence. So what is the probability of just that one creature of all, let's say, let's put it as conservatively 10 million species, one of 10 million possess intelligence? That's exceedingly, exceedingly rare. Chances are very, very, very low. Mathematically, it's almost impossible. It is easier for someone to be hit by lightning twice on the same place than for a creature with intelligence to arise from, billions of, oh no, sorry, not billions, from millions of species. So probability is very, 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 very small. So even that habitable planet has species, right, creatures living on it. Not all of them can give rise to intelligent creatures. So you narrow the scope down according to Drake. Then from that, even if you have that planet, you have intelligent beings, right? That can, they can, create mathematics, science, technology, and so forth, right? But how many of these intelligent creatures have sufficient time on their planet to, you know, uh, to communicate and tell others its presence, just like us? We have been telling whatever, if there are creatures out there, we've been telling all these creatures that we exist on this planet Earth. We exist, right? And how can we tell them? We broadcast our television signals out there to space, our radio signals, right? Our internet, all these things, as all these broadcasts, all these signals, right, escape from Earth and travel all the way from all direction of the Earth out there to space at the speed of light. And so therefore, that the first television series, which was published, well, maybe in 1930s, right, the signal was sent out. And so this signal escaped the Earth. All television signals escape Earth, and it has been traveling across space for almost 80 years or 90 years, right? 80 to 90 years. So it's been traveling across space for 90 years. So if there are stars that are closer than 90 light years away from our sun, and if those stars have intelligent creatures, they surely will know that we exist on solar system, on this third planet, the third rock of the sun, because we have been broadcasting, and they can monitor actually the progress of our civilization, how we destroy ourselves, how we fight among each other, because we are telling all across the universe what is happening on Earth by our television and radio broadcasts. But this only can give rise if there's sufficient time for this intelligent being, right, to produce that technology. So from this Drake's equation, right, in a nutshell, it shows that for a planet to give rise to creatures like us, intelligent being that can broadcast its presence to all in the universe by way of radio signals, television signals, whatever, right? That planet is exceedingly rare, very rare, right? Because you have a lot of factors if to multiply for until you can get that number of planets that can give rise to creatures like us. So Drake's equation shows that Earth is a planet that is very rare in this universe, or at least in our in our Milky Way galaxy. Very, very difficult. So this Earth is actually very precious, very precious. Until now, astronomers cannot find any other planets that contain water as much as Earth. 70% of Earth's surface is water. So we are living in a very beautiful, delicate, once in a lifetime spaceship. It's a prototype actually. There is no other spaceship like Earth. But even if you know that, humans are foolishly, unwittingly or wittingly or purposely destroy the spaceship that you're living on. we are destroying our own planet, right? With whatever pollution that we're producing and the carbon dioxide that we've been releasing. It is as if we don't care about the welfare of the planet. Just look, Brazil. Uh, Brazil is always at the mercy of the one who becomes a president. Before the current president, the president before it, he took care of Amazon jungle. But the current president, Jair Bolsonaro, became the president of Brazil. He actually accelerated the deforestation of Brazil in the name of business, because he is actually a businessman, and his motive is wealth. And wealth is it can already come from Amazon, and to do that we need to cut down Amazon jungle. So and millions of hectares of Amazon jungle has been cleared during his administration, and he's still ruling Brazil, and he's still cutting down the Amazon jungle. So when people tell him, look, you have to take care of this, because future generations need this jungle, and this planet needs this jungle to produce oxygen and for other creatures to live. And he said, we don't care. I don't care. This is my country, and it's a sovereign country. I can do whatever I want. If I want to cut the whole Amazon jungle, who can stop me, right? And if you say that will affect other this planet, other countries in the future, say it's not my problem, right? I'm being elected by the presidents to enrich them, to bring more wealth, not to bring prosperity to the whole planet. So I don't care about the whole planet. It's not on my job scope. So that's how foolish some people are right now when they become, leaders of their countries, and whether it be president or prime minister or kings or whatever. So we're destroying our own rare planet. Now, to show how rare it is, there is another equation, right? It's called rare earth equation, which is an improvement of Drake's equation with a lot number more factors coming into this equation, and every of these factors, FPM, NE, NG, FI, so forth, it narrows down the scope of the chances of a star that has a planet that can give rise to civilization like human beings. Or in other words, right, it is narrowing the scope, or it shows the overall picture of how rare a planet like Earth can exist in this vast universe. So not just it must be planets with star-rich, so metal-rich planets, if metal-rich stars, and it must be in habitable zone. It must also exist in stars habitable zone, and must also exist in galactic habitable zone. It means that what? It means that if, let's say, that star exists in a neighborhood of stars that are very close nearby, so that planet orbiting that star will not be stable. It will be flung away from the sun, or from the star, from its star a moment, and then be flung towards its star again. So hot, cold is not stable. Now, galactic habitable zone, right now our sun, right, is orbiting around the galaxy, and our sun is in a zone, we call it as a quiet neighborhood. Astronomers call it as quiet neighborhood, because why? Because stars are spread out widely. But our sun is actually now moving towards a zone where all the stars are closer than the zone that we are in right now. So once the sun enters that zone with its planets moving together, its solar system moving together with it, all its children moving towards it, right, towards that densely packed stars, we call it the galactic arm actually, then life will become unstable, because stars will be just orbiting around sun anytime and disturb our planetary movement, and then it might be cause all these stones and meteorites and comets to be disturbed, and bombards, billions of them become bombarding the planets of that star or our sun itself. So we are actually living in a galactic habitable zone. So everything actually Allah SWT has planned out. And when the sun is in its galactic habitable zone, that's when, right, humans come to live on Earth. So when everything has been stabilized, when sun is in a quiet neighborhood, then only then Allah SWT send down Nabi Adam alayhi salam on earth, and therefore we as children of Nabi Adam alayhi salam, we lived quite comfortably, not that much distraction from space. Why? Because of this quiet neighborhood of our galaxy that our sun is in right now. Okay, so then after that, there are other biological factors that this equation takes into account, just like metazoans. What is the percentage, what is the chances of metazoans arise from that on that planet, and then a complex metazoan after that. Is there a large moon or Jupiter-sized moon? How many mass extinctions are there? Is it low or is it high? All these determine whether there will be ultimately a thinking creature that lives on the planet that can possess the ability to build technology from science and also mathematics that this creature, built upon. And so rare earth equation and also Drake's equation together tells us that our earth is actually very, very, very rare in this universe. So rare that we actually can say safely that there is only one earth in this vast universe. Well, we do not know ultimately whether there is one earth or not, but as of now, our current knowledge is pointing towards that, which is what there's only one earth or one planet that is similar to earth, and that is our planet itself. Earth is very, very rare. So the creation of the earth is actually something that is wonderful, something that is even one in a billionth billion, and that's why it is so special that Allah puts Nabi Adam alayhi salam on earth instead of other planets in other planetary system, but on earth itself, because Allah deliberately created earth so beautifully and so nice for us to live. And when Allah SWT wants to put humans on earth, right, Allah SWT created Nabi Adam alayhi salam from the clays, and from the earth, whatever, clay, sands, earth, when you call it, from this planet itself, and then fashion Nabi Adam alayhi salam, breathe into him the ruh, and then Nabi Adam rose up and become alive. So we are the children of this beautiful planet Earth. So it might be one only in this vast universe. So please take care of our Earth, right? This is very, very precious for us. We destroy our Earth, there's no other place for us to go. So, don't be wasteful. Always try to recycle, reuse, right, and reduce usage, so that this earth can continue to be habitable for future generations and for other animals. All right. So these are the two equations. This one tonight is just to give a picture of how rare the earth can be. If you come to the conclusion that this whole universe, there's only just one earth, then we can move on to that ayat of 7 earth. What does it mean by 7 earth? And that, inshallah, we conclude next week, inshallah. And that is the conclusion of our series of lecture. So next week will be our final lecture, inshallah. So I see you next week, right? Inshallah, if let's see. Oh yeah, you have somebody asking question. There's no question here, just a comment. So alhamdulillah. So thank you very much. Have a very good evening and a very blessed knowledge from Allah subhanahu wa ta'ala, and so that this lecture, especially tonight's lecture, will make us more appreciative of these blessings and this ni'mah that Allah has given us in the shape of our beautiful planet, just like behind me, this planet. All right, so we end with Tasbih Kafara and Suratul Asr. Subhanakallah bika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Al-asr al-insana fi khusr illa alladhina amanu wa amilus salihat wa tawasaw bil haqqi wa tawasaw bis sabr. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.